little bit how to calculate the range of the atomic element that we need to copy. So we know for an image, like we have this atomic element here, and we're gonna copy that to fill the whole periodic image. But how are we supposed to know, like, what's the end? Like, because there can be infinite here. So we have to remember that the boundary. So we have a square image here. So the boundary will be defined by 4 corners. So we have 4 coordinates here, and we can actually simplify this problem to, like, how many other location base for the other atomic elements do we need? For example, here we have this atomic element here with this the given location base, and we need to find the other location bases for other atomic elements, which is indicated by these gray points. So for example, this points, the nx should be 2 and ny should be 1. So what we care about is, like, the most corner ones. So how do we get that? So for this particular task, I used to use the very silly one, is that I make a huge, like, outsider this image. So I can copy. I don't care about this boundary. I just make this huge, insanely sillily big. But the solution is not like that, even though they can succeed. So for calculating the range, we need a little bit about the math. Like, yes, we need little bit about math. We gotta remember from the lecture. So for this periodicity to work, it's actually linear transformation. For example, take a look at this part. So, for example, we have this base, where this location base coordinates given to us, and we have the periodic matrix with 2 vectors 1 and vector 2, and this is actually, the number, like the I call it stretch factors, stretch factors, or whatever. This is just my own name, don't care about that, just easier to understand. So it's actually like this: decide how many vector 1, and y decide how many vector 2 we need to reach the point we want. So we want to set this point to one of these corners. Like, take a look at this, so we can know, like, how far, like, how big or how small or how negative or how positive this needs to be. So this is actually very simple linear transformation equation, which can be solved by MATLAB. For example, take a look at this part. For example, we have a 1 base, location base, and periodic matrix is this is a simple one, and we want to reach this corner point, which is like this here, for 450. So the result will be 2.245. So this is fractional. This has decimal numbers, which means actually we need not just 2, we need 3. Just take a look at this part. So 1, 2, 3. So the copy operation will be number of 3 instead of 2. That's why we need to round this to 3. But sometimes we need to round it to like the lower one. For example, if this result of this calculation is minus 2.7, we need to use another function called, I think MATLAB is floor. so it turns to -3. Yeah, so that's basically the key idea of this part. Oh, by the way, thanks to our another tutor, Bo and Son. Like, he gave me this very beautiful note. I actually didn't use this method until he told me. I actually didn't understand the solution, but well, much appreciated to him. I think this part is clear to me. So this is basically, so this step 2 is basically the summary of the key idea we just talked about. Instead, we can combine those 4 calculations into just one matrix. One matrix calculation. Made like this calculating process. Just remember, like, there you need to do a little bit of reformatting this. Like, for example, we're gonna move this part, so this corner will be like, we're gonna do a shifting of coordinates, because our coordinates is our location base here. So you will see here why we minus this location base is just because we, put this to the right half. And with a little bit of MATLAB operations, like we put, and this is basically the summary, right? Floor, sill, and this is floor is for like the minus value, the sill is for the maximum value. Then we have the range. Then we can, so the problem is basically solved after we know this, how to calculate the range. And I think this is how we do with this task.